So, a subset is a set that contains, there we go, a subset is a set that contains some or all or possibly none of the elements from a previously defined set. All of the sets that we're going to deal with are subsets of the universal set, and every set is a subset of itself. So, in set notation, the symbol this is used to represent this relationship between sets. For example, E is a subset of U, since all the elements in set E are also in set U. So if we're looking up here, so E is, so the entire, this was our universal set. So E, using our proper notation here, is a subset of U. All right, so is set E a subset of L? So does E contain all of the numbers that are in, or does it have only numbers that are in L? It does up until this 8 right here. Because of that 8, because of that 8, E cannot be a subset of L. So then next it asks, is O a subset of L? So is O a subset of L? So I'm looking at the numbers in O. O has 1, O has 3, O has 5. That means that O is a subset of L, and that's the subset symbol. And it's also a subset of U, which is the universal set. So, and then we start talking about empty sets. So, an empty set is a set that contains no elements. The empty set is a subset of every set. So, the notation for the empty set is empty set. For example, the set of all odd numbers is in set E because there are no odd numbers in set E. So let's look at coming up with another example that is an empty set of of one of these sets that we've got going on here. So for example, one of the things I could look at is this one. Now, this contains only odd numbers in set O. So an empty set would be even numbers in set O. Now this would be an empty set because there are no even numbers in set O. There's only 1, 3, and 5. So another example could be like 4 in set O, or odd numbers greater than 7. So you have unlimited choices for empty sets. A complement of a set. A complement of a set A is the set of all elements in the universal set that are not in set A. So the complement of set A is denoted by A prime. So if we write the complement of set E using the appropriate notation, so we'll just kind of scroll up here and we'll look at set E. So remember our universal set was single digit numbers. So that's going to be all the numbers that's less than 10. So our E prime, now these are all even numbers in set E. So our E prime, or our complement of the set, is going to be 1, 3, 5, 7, and 9. Now note this is the exact opposite. This is all the stuff that wasn't in the first one. So if we're looking at these two sets here, A is natural numbers less than 20 divisible by 3. B is natural numbers less than 20 divisible by 5. So why is the set of natural numbers less than 20 a suitable set? So this just is because all the elements being considered are in that universal set. So I'm just going to kind of highlight this here. So natural numbers less than 20. So natural numbers is in both of these things. Less than 20 is in both of these things. The only way that these two differ are in this, what they're divisible by. So it makes sense to have that as your universal set, because we know for a fact that these numbers, or sorry, that both of these sets, A and B, are within that universal set. So if we want to list all the elements in our sets here, so we have A. A is natural numbers less than 20, excuse me, that are divisible by 3. So this is going to be 3, 6, 9, 12, 15, and 18. Literally all we're doing is counting up by 3s. B has less numbers in it. It's just going to be 5, 10, 15. Now, a reminder, this was the less than 20. It's not inclusive. It's not inclusive of 20, not including 20. So A prime is the opposite. So it's all the numbers in that universal set, which we already decided was numbers less than 20. So it's going to be all the numbers that are in that numbers less than 20 that are not already included in A. So what we're looking at there, 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. So then it's asking, write a description of the elements of the complement of set B in words. So the complement of set B, or B prime, all right, so we could write them all out. There's a lot of them. Or we can say natural numbers. So that's our counting numbers. Natural numbers that are less than 20. Not divisible by 5. So that's in words. We can always say those things in words. So now it's saying C is our natural numbers less than 20 that are multiples of 6. So state whether the following are true or false. So C is a subset of A. So it's saying that A is like the daddy, and A holds everything in C inside of it. And it's saying C has multiples of 6. So we know that every single multiple of 6 has to be divisible by 3. So this one has to be true. For our next one here, it's saying that C is not a subset of B. So it's saying that B, that's going to be our daddy one here, saying that B, which is 5, 10, and 15, is not going to hold everything that's a multiple of 6 inside of it. That's 100% true, because 6 is a multiple of 6. We don't have 6 in our B set. We don't have 12. We don't have 18. And those would be the only numbers in it. So that's obviously going to be true. Now, A prime is a subset of C prime. So basically what they're saying there is that are all the numbers that don't work for A, which is A prime, are all those going to be inside of C prime? Now, if we think about this logically, C prime has way more numbers in it than A prime does, because C prime only excludes 6. So this one's just going to be 6, 12, and 18. So of course A prime has all those things. A prime is a subset of that because C prime is going to have way more numbers in it. So all 3 of these statements are